Ladies and gentlemen, can we take our stand as the Vice Chancellor leads the procession for the inaugural lecture into the auditorium? We will remain standing. We will take the national as well as the future anthems. Shall we double the applause as we take our seat? Distinguished ladies and gentlemen, my Lord spiritual and temporal, members of the uniformed services, great Futurians. On behalf of the leader of our academic community, our Vice Chancellor, Professor Adenike Tedidayo Olakitan, I welcome us to the 180 talk in the inaugural lecture series of our university. Today's lecture with the title, Waste Engineering and Climate Change, an Ingenious Alliance to the Drawdown, will be delivered by Christianah Ijagbemi, Professor of Mechanical Engineering, Energy and Environment. A round of applause for the inaugural lecture. In line with the established tradition of our institution, today's ceremony will be presided over by our Vice Chancellor as its chairman. And let me, in line with tradition, introduce to us the very first female Vice Chancellor of this great university, Professor Adenike Tedidayo Olakitan. A round of applause for Madam Vice Chancellor. On that side of the divide, we also have key members of our university management. With the Vice Chancellor, we have the Deputy Vice Chancellor, Academic, Professor Taiwo Timothy Amos. The Deputy Vice Chancellor, Development, Professor Sunday Samuel Uluyamo. You are welcome, sir. The Secretary to Council, the Chief Scribe of our institution, who is also the Registrar, Mr. Charles Olusegun Adeleye is also with us. The Chancellor of the Exchequer, Abosa, Mr. Peter Oshaduba, you are welcome, sir. The University Librarian, Dr. Robert Akiade Awoyemi, we welcome you, sir. And now for our days. For the first time as the chairman on charge of this institution, this is his making appearance in that key position. Professor Boniface Kayode Alishi, Dean School of Computing, Chairman, Committee of Deans of our great institution. Also for the first time in his capacity as Dean School of Agriculture and Agricultural Technology, Professor Olabode Thomas Adebayo, we welcome you, sir. The Dean School of Basic Medical Sciences, Professor Akim Olakitan, you are welcome, sir. And also, for the first time, in his capacity as the Dean School of Infrastructure, Mineral and Manufacturing Engineering, Professor Christopher Olukumi Akibele, you are welcome, sir. The first elected Dean, making his maiden appearance as the first elected Dean of the School of Electrical Systems Engineering, Professor Adekoke Oladipo Memundi, you are welcome, sir. The Dean School of Health and Mineral Sciences, Professor Ayodeji Oluleye, welcome you, sir. Also making his maiden appearance as the Dean School of Environmental Technology, Professor Joseph Omoni Basharon, you are welcome, sir. And the Dean School of Logistics and Innovation Technology, Professor Olayiye Olaseni Simon, you are welcome, sir. Making his maiden appearance as the Dean School of Life Sciences, Professor Muftau Kolawole Olatunwoye, we welcome you, sir. The Dean School of Physical Sciences, Professor Femi Barnabas Adebola, you are welcome, sir. The Dean School of Postgraduate Studies, Professor Oluwayo Bello Olusoji, we welcome you, sir. And the Dean that commands the largest contingent of forces on this campus is Dean Student Affairs Division, Professor David Olanwaju Obuke. You are welcome, sir. At this point, it's my pleasure and privilege to invite to the podium our Vice Chancellor to deliver our address. Madam Vice Chancellor.
The Pro-Chancellor, Olabisi Onabanjo University, Professor Ashley, the Deputy Vice Chancellor, Academic, Deputy Vice Chancellor Development, the Registrar, University Librarian, the Bossa, my lords, spiritual and temporal, top government functionaries here present, the inaugural lecturer of today, Professor Christianah Ijagbemi, deans, directors, and heads of departments, particularly the Dean of the School of Infrastructure, Mining, Infrastructure, Mineral and Manufacturing Engineering, distinguished members of Senate and congregation, eminent scholars and friends of the university, gentlemen of the press, distinguished ladies and gentlemen. I welcome you all with great pleasure to the 183rd inaugural lecture of the Federal University of Technology at Prof. I warmly welcome our spiritual and traditional leaders, top government functionaries, captains of industries, friends of the university, and the entire staff and students of the university. I am delighted to welcome the immediate and extended family members, friends, and well-wishers of the inaugural lecturer. I felicitate Professor Christianah Ijagbemi on this academic milestone. May I, at this juncture, request the inaugural lecturer to please rise while I present our citation. Professor Ijagbemi. Christianah Olakitan Ijagbemi was born November 29, 1969 in Akure, Ondo State. She attended Akure City College, Akure, for her secondary education, obtaining the West African School Certificate Examination Certificate in 1986. And she proceeded to Federal Polytechnic at Olakitan, where she got her OND in 1989. Thereafter to Yaba College of Technology, Yaba, Lagos, where she got her HND in 1992. She attended the Federal University of Technology at Prof, and she obtained postgraduate diploma in mechanical engineering in 1998. Masters in Mechanical Engineering in 2002, and proceeded to Ewa Women's University in South Korea, where she obtained PhD in Environmental Science and Engineering in the year 2010. Christianah Ijagbemi joined the services of the Federal University of Technology as Technologist 2 in 1995 in the Department of Mechanical Engineering, School of Engineering and Engineering Technology then. She began her lectureship career as assistant lecturer in the department in 2003 and was appointed professor in the year 2019. Most notably, she holds the singular honor of being the first female professor of engineering in FUTA, and also the first female chair, Nigerian Society of Engineers, Ondo State. Professor Christianah Ijagbemi has supervised 22 master's degree dissertations and 6 PhD theses to completion. She has served as external examiner to several institutions in Nigeria and across France, Australia, the United States, and South Africa, among others. Professor Ijagbemi's research focuses on energy and environmental engineering, green manufacturing, climate adaptation, skill development, and wastewater remediation. Our publications, posted in reputable international journals, with many works surpassing the 50 citation benchmarks. And this is as indexed by Google Scholar. She's a reviewer for several academic and professional journals. Prof. Christianah is the recipient of PhD tuition scholarship of Era Women's University. She is a recipient of the Faculty for the Future Scholarship Award by Scopide in 2009 and a postdoctoral fellow of Australian University of Technology in South Africa between 2015 and 2017. Prof. Christianah Ijagbemi is a fellow of the Nigerian Institution of Mechanical Engineers, also a fellow of the Nigerian Society of Engineers. She is a member, Board of Fellows, Nigerian Institution of Mechanical Engineers, a member, Current Engineering Regulation Monitoring Committee, and a member, Board of Technical Directors, National Agency for Science and Engineering and Infrastructure, Senate. She has had years of experience both in lectureship and management positions in the university system and has served the university in many capacities, such as she currently serves as the director of the Center for Gender Issues in Science and Technology, SDGs, from 2021 to date. She is chairman, Steering Committee on Responsible Artificial Intelligence for Climate Action in Africa, a position she has held from 2022 till date. She's a member, Board of Management for the Center for Continuing Education. She was a member, Future Ranking and Image Committee. She was a member, Appointment and Promotions Committee of the School of Engineering and Engineering Technology, and she was Registration Officer 200 level for the Department of Mechanical Engineering. Outside the university, Prof. Christianah is a deaconess at Agape Christian Assembly at the Distinguished ladies and gentlemen, the lecture of today emphasizes on the urgent need to harness waste engineering as a frontline climate solution. The lecture is expected to enlighten us by demonstrating how engineering principles can transform waste into energy, resilience, and sustainability, aligning with FUTA's mission to drive knowledge that responds to global challenges and empowers communities towards a low-carbon circular future through innovative research and green technologies. Distinguished ladies and gentlemen, we have before us this day a distinguished scholar to present the 183rd inaugural lecture of the university titled Waste Engineering and Climate Change, an Ingenious Alliance to the Drawdown. Please join me in welcoming Professor Christianah Olakitan Ijagbemi.
The Vice Chancellor, Deputy Vice Chancellor Academics, Deputy Vice Chancellor Development, Registrar and other principal officers of the university, deans and directors, heads of departments and heads of units, members of Senate, members of the University Council, past and present, my lords, spiritual and temporal, royal majesties, my immediate and extended families, distinguished academic, administrative and professional colleagues, distinguished guests and friends of the university, gentlemen of the press, ladies and gentlemen, great Rotarians. Madam Vice Chancellor, distinguished guests, colleagues, and friends, it is with a deep sense of humility, honor, and heartfelt appreciation to Jehovah Elohim, the Most High, that I warmly welcome you all to the 183rd inaugural lecture series of the Federal University of Technology. All glory and adoration be to the Almighty God, who has made Engineering at FUTA to achieve this distinction. So this lecture marks the 5th inaugural lecture in the Department of Mechanical Engineering and the 4th within the Energy and Environment Research Unit of Mechanical Engineering. Notably, the very first inaugural lecture from the unit was delivered in 2002 by the late Professor Ijagbemi, Cyril, titled Energy as a Veritable Tool for a Sustainable Environment. Madam Vice Chancellor, esteemed members of the academic community, distinguished guests, today's lecture addresses a subject of urgent global significance, one that affects every living being and the very fabric of our natural world: waste engineering and climate change, an ingenious alliance to the Drawdown. This presentation highlights a 30-year journey in teaching and research within the field of mechanical engineering, with a dedicated focus on energy and environment. Throughout this journey, my academic pursuits have consistently aligned with global Drawdown strategies aimed at fostering a more benign and sustainable environment. It is particularly gratifying to note that these efforts have attracted support from both governmental bodies and corporate organizations, leading to strategic collaborations with universities and research institutes across the globe. From the early days of my childhood, I lived and learned without boundaries. I was born the first of 6 children from my mother and the first of 13 from my late father, and a natural leader. I was surrounded by siblings and playmates, many of whom were boys, but never noticed the difference between us. We climbed trees, raced through dusty streets, and challenged one another with wild games and rough games. To me, gender was relevant. Courage, curiosity, and determination were more important. The unshaken sense of equality became a guiding force in my education. All through schooling, I consistently taught my class, not as a competition, but driven by a quiet, persistent hunger to learn and to prove that I belong where I chose to be. I excelled in mathematics and science, never shying away from problem solving and hands-on projects. Yet, I was often reminded, sometimes gently, sometimes bluntly, that I had a name. Those were stopped, but they never stopped. If anything, they ignited in me a fire to do more and go further. When it was time to choose a career path, I followed my instinct into a field really considered unconventional for someone like me: engineering. It wasn't rebellion, it was resonance. The logic, the structure, the real-world impact all spoke to me. What I didn't anticipate, however, was how startling my identity as a woman to reveal what engineering was. I found myself one of the few females in lecture hall, at lab tables, and on technical project teams. It wasn't in that phase that I began to recognize the uniqueness in my journey, not as a disadvantage, but as a distinction. I came to understand that being a woman in engineering wasn't about overcoming my femininity. It was about embracing it. It meant leading, defending, thinking creatively, and also contributing meaningfully to the environment. Over time, that space of passive difference became a place of pride. My early belief that we were all the same, male and female, gave way to a deeper truth. We may not be the same, but I am equally capable, equally necessary, equally deserving a place at the table. a woman who has strived in engineering, I stand as a living proof that gender is not a limitation, but a lens through which creativity, empathy, and resilience can flourish. Engineering is a vast multifaceted field, and its definition reflects its diversity. Engineering has numerous definitions, with each definition emphasizing unique aspects of engineering. Highlighting this complex setting and importance, engineering depends on the context in which it is applied, the waste world, and the world of waste. Madam Vice Chancellor, this phrase seems compelling. It suggests two great things, but interconnected ways. The waste world implies a shadow economy built around waste, including global recycling industries, waste management institutions, and illegal dumping networks. While the world of waste highlights the sheer level of discarded material, shaping our planet from overflowing landfills to microplastic in the ocean and the effects on our environment. Then what is waste? Waste refers to materials, substances, or items that are no longer needed, usable, or wanted, or are often discarded, or undesirable byproducts of life. We can simply put waste as items that are no longer considered useful or necessary. Then the psychology of waste. This examines why individuals and society produce and ignore or manage waste differently. Meanwhile, the geography of waste explores how waste is distributed, processed, and impacts different regions. Developing towns and cities in Nigeria face the dual burden of rising waste generation and insufficient infrastructure for collection, treatment, and disposal. This imbalance exacerbates environmental and health risks, creating a national crisis in need for urgent attention. Is there anything called waste? Waste is simply a matter of perception. For instance, materials we classify as waste can also be recycled, upcycled, and repurposed. Food scraps can become compost. Plastic bottles can transform into art or building material. And wastewater can be treated and reused. The idea is that waste exists because we lack systems, technologies, or behaviors to utilize this waste effectively. Why waste matters? Why waste matters? Because the existing management policies are not effective in addressing poverty and waste pollution. This is SDG 1. The Sustainable Development Goal 2 talks about how to combat hunger globally, and says food waste can be converted to manure to replenish our depleting soil nutrients. SDG 13, that's the topic of today, says pure waste management generates harmful emissions that contributes to climate change. The sustainable goals cannot be met unless the waste management is addressed as a priority. Then what is waste engineering? Waste engineering, also known as waste management engineering, is a specialized branch of engineering that focuses on the efficient and sustainable management, treatment, and disposal of waste material through technological innovation, systematic planning, and resource optimization. Waste engineering often avenues for energy recovery, resource conservation, and pollution control. The science and the climate change. The goal of climate change science lies in the greenhouse effect, a natural process where certain gas trapped heat within the Earth's atmosphere. Maintaining temperatures conducive to life. Human nations, however, have amplified this effect, leading to global warming and broader climatic shifts. Gas like carbon dioxide, methane, nitrous oxide, and fluorinated gases are released into the atmosphere through activities like industrial processes and waste management, burning of fossil fuels for energy and transportation, deforestation, reducing the Earth's ability to absorb CO2, agriculture and livestock, which emit methane and nitrous oxide. All these contribute to the greenhouse gas emissions. In response to the escalating challenge of climate change, international agreements have become critical in orchestrating a coordinated global response. The Paris Agreement, adopted under the United Nations Framework Convention on Climate Change, is a landmark agreement where nearly every nation has committed to limiting global temperature rise to well below 2 degrees centigrade, above the industrial level, with an aspiration target of 1.5 centigrade. The annual conference of the Paris meeting, such as COP21 and subsequent summits, provide a continental forum for nations to negotiate emission targets, review progress, and share best practices. These forums are instrumental in aligning national direct impact of waste mismanagement. Uncontrolled waste disposal has far-reaching consequences for both human health and the planet. According to the Intergovernmental Panel on Climate Change, waste contributes approximately 55% of greenhouse gas emissions. In short, mismanaged waste is both a contributor to and consultant to climate change. Waste engineering plays a vital role in achieving sustainability and protecting the ecosystem. The Ingenious Alliance. In the context of this lecture, Ingenious promotes the innovative problem-solving approach of engineering, which aligns or agrees with climate solutions to pursue mutual beneficial objectives of carbon drawdown. This lecture presents a partnership between waste engineering and climate solutions, in which two stakeholders contribute uniquely to achieving outcomes that provide a better environment. Examples of such alliances are seen in academic industry collaborations, joint research endeavors, or strategic business partnership, where the primary intent is to enhance connective ingenuity and drive transformative change. Satellite monitoring, digital tracking, and AI sorting systems now offer scalable solutions to managing waste streams effectively. The increasing integration of real-time monitoring and process control technologies such as sensors, Internet of Things devices, and data analytics allow operators to fine-tune combustion parameters, improve reaction efficiency, and reduce pollutant output. Such technological integration is vital in enhancing operational performance and meeting the emission standards set by international agreements. Data obtained from these systems also contribute to the validation of environmental impact models, ensuring that processes of conversion, non-recyclable waste introduces energy are economical and ecologically stable. Alignment with global drawdown strategies. The concept of drawdown is the point at which greenhouse gas concentrations in the atmosphere begin to decline. This has become a focal target in global climate policy and work. According to the Global Waste Management Act of 2024 by UNEP, global municipal solid waste is projected to rise from 2.1 billion tons in 2023 to 3.8 billion tons in 2050. With poor waste practices like open dumping and burning within from landfills, we continue to contribute significantly to greenhouse gas emissions. The integration of waste engineering and drawdown strategies is grounded in quantifiable environmental benefits. Mindfulness contribution to knowledge. It is estimated that each person generates a minimum of 2.5 kg waste per day. What then do we do with the waste we generate? Madam Vice Chancellor, today I am honored to contribute to a more sustainable future, one in which waste is no longer seen as a burden, but as a valuable resource that supports both economic growth and environmental well-being. For over 3 decades, I've actively engaged in collaborative efforts with fellow academics, engineers, and key stakeholders in the domain of waste engineering and climate change. These collaborations have principally focused on the design and development of scalable systems, technologies, and process aimed at advancing global environmental sustainability goals. The collective impact of this research efforts is evidenced by almost 1,500 citations recorded on global scholars, underscoring the academic relevance and record of capability. Some of my scholarly contributions is alleged in the following section. Smart grids and the wonder of multi-millionaires. Madam Vice Chancellor and distinguished candidates, Ijagbemi and Acknowledgments in 2005 reported the first ever scientific and applied platform in multi-millionaires, a multi-millionaires, classified as smart grid. In exploring local evidence of multi-millionaires for industrial application, he put a claim was investigated for application of mining material from biomass fuel. We characterized the bullet benzene and compared it to other benzenes used in manufacturing industries as shown in Figure 5. Ijagbemi and Acknowledgments in 2004, Ijagbemi in 2005, Ijagbemi and Acknowledgments in 2006 established and documented that a bullet benzene is a multi-millionaire selector in the system can replace 57 to 87 million foodstuffs in Africa, avoiding 4.6 to 9.7 megatons of carbon dioxide equivalent emissions. Premise of this, we reported the use of multi-renewable, a smart player that is later in the development of the biomass clean-line foodstuff, as shown in Figure 7. We published, communicated, and encouraged NGOs in southwestern Nigeria, and the first lady of Ondo State, then Mrs. Kemi Ijagbemi, who through a collaboration with the Ministry of Women Affairs and Social Development and with the Department of Mechanical Engineering Center to produce foodstuff distributed to rural women in Ondo State and the southwest of Nigeria. As alleged in Ijagbemi and Adeloke 2004, Ijagbemi and Adeloke 2006, the growing advocacy by the Nigerian government and number of major organizations for cleaner cooking alternatives affirm the urgent need to scale up the distribution of biomass foodstuff. Such interventions will significantly improve public health, conserve natural resources, and contribute meaningfully to the broader climate goals, particularly the much desired drawdown in carbon emissions. Biofuel is one clear tool. In recent years, rising global health crisis, widespread forest depletion, and increasing electricity costs have contributed to a growing interest in alternative clean energy sources. Ijagbemi 2002, Ijagbemi 2005, Ijagbemi and Adeloke 2004, Ijagbemi and Adeloke 2006, and Ijagbemi 2025 documented the development of complex foodstuffs designed for household use as an alternative to conventional fossil fuel and wood-based cooking methods, as shown in Figure 8. These foodstuffs have been shown to reduce greenhouse gas emissions and improve indoor air quality. My research team developed ethanol fuel derived from banana and cassava clean waste to evaluate the operational efficiency of a weakest foodstuff. Findings indicated that the stove combusted the biofuel cleanly, producing no smoke or odor, even when extinguished. Additionally, we recommended the biofuel as clean energy solution to replacing fossil fuels and other concerns contributing to the greenhouse gas emission. Green amenity. Development of biosolvents for industrial wastewater remediation. In addressing environmental pollution resulting from heavy metal contamination in industrial effluents, my research team examined the applicability of multiple elements owing to its distinctive surface properties and suction capacity. Madam Vice Chancellor, it is noteworthy that this particular research focus has gained significant scholarly attention, accumulating over 500 citations of global scholars. Heavy metals such as lead, cadmium, nickel, and copper are known to persist in aquatic environments, posing significant toxicity risk over time. These contaminants have become a growing concern due to the adverse effects on ecosystems and public health. Ijagbemi and Adeloke 2008A, Ijagbemi and Adeloke 2008B identified multi-renewable as efficient and favorable adsorbents for the remediation of industrial wastewater. Further, Ijagbemi 2008, Ijagbemi 2009 investigated the electrochemical properties of multi-renewable, evaluating the points of zero charge and advancing ionic strength and establishing the values at 3.4 as shown in Figure 9. Our findings figure 12, that the efficiency indicating strong potential for scalable environmental application and circular economy integration. Agro-waste biosolvents for every metal removal in wastewater. In Ijagbemi 2010 and Ijagbemi 2010A, Ijagbemi 2010B, we reported on the efficacy of discarded charcoal, commonly referred to as spent charcoal, and cassava peels as absorbents of pollutants such as methylene blue and heavy metals. Premise on this, a wastewater treatment unit as shown in figure 13 was developed within the central workshop of the Federal Minister of Technology to evaluate the subject capabilities of dried cassava peels on heavy metal contaminants in effluent streams. The treatment of gold plating wastewater confirmed the effectiveness of waste cassava derived biosolvents for metal removal. Specifically, the unit achieved a removal efficiency of about 80% for copper, 73% for lead, and furthermore, the system provided complete removal for zinc, for gold, and chromium ions from the wastewater samples. Madam Vice Chancellor, my findings reveal the viability of agro-waste conversion into functional biosolvents, offering a cost-effective and environmentally beneficial strategy for wastewater purification. The approach was not only validated agricultural residents, but aligned with sustainable waste management practices for greenhouse gas emission drawdown. Ozone oxidation from the composition of diatomize in industrial effluent. As part of our ongoing research efforts to advance the remediation of that pollutants in wastewater, Madam Vice Chancellor and distinguished guests, we explored the alternative composition of malachi and ASO Red 27 through ozone oxidation. Ijagbemi 2010, Beck 2009B, Beck 2010, and Beck 2010B. Remarkably, our findings indicated that within just 5 minutes of ozone treatment, color removal in malachi contaminated wastewater from the dyeing industry reached approximately 92%. The rapid depolymerization has found the effectiveness of ozone oxidation as a vital method for dye effluent remediation with its potential to reduce greenhouse gas emissions. Reducing carbon footprint through waste management. Bioplastic from waste. Madam Vice Chancellor, my findings in the past 20 years have been in the quest of providing solutions for reducing carbon emissions. Ijagbemi 2014 and Ijagbemi 2022 developed biopolymer theories from sweet potatoes to produce bioplastic products, as shown in figure 15. This innovative research reported relevant data on how polymer films can be developed for sweet potatoes, which are easily grown in Nigeria. The bioplastic we developed is completely degradable by composting, and it is applicable for food packaging. Biogas from waste, while recycling is not feasible, converting waste into energy through anaerobic digestion or controlled incineration can provide cleaner energy alternatives. Ijagbemi 2018 reported on the production of biogas from coal digestion of food waste and cow dung, as shown in figure 16. Waste from cooked and uncooked food were converted to useful energy in form of biogas, which can be employed for domestic purposes, as shown also in figure 16. Solid waste management. Waste as an economic asset. Ijagbemi 2010, Ijagbemi 2014, Ijagbemi 2014, Ijagbemi 2016, Ijagbemi 2017, Ijagbemi 2018, Ijagbemi 2019A, and Ijagbemi 2019B. Reported that in terms of climate benefits, waste prevention is the best management option. Recycling will avoid 10.3 to 11.2 gigatons of carbon dioxide equivalent emissions by 2050. Madam Vice Chancellor, and extinct audits. In 2009, my team and I partnered with the Ondo State government on an integrated waste management program, Ondo State Integrated Waste Recycling and Treatment Program. In January 2010, informed that the company recorded huge success in recycling waste generated in Akure by the development of valuable products, home composting, and turning waste into organic mineral fertilizer. Furthermore, January 2014 reported development of a home composting machine for converting plastics as the Vice Chancellor. Plastic pollution is not just a marine choice. It also plays a role in climate change. Due to its explosive wild origins, Ijagbemi 2011 developed a plastic shredding machine. The plastic shredding machine was an assembly of so many components. Paper recycling machine. Recycling of paper decreases the demand for vital small and thus reduce the overall amount of air and water pollution associated with paper manufacturing. My research team made an attempt to recycle newspaper. Ijagbemi a conveyor belt system. The machine was engineered to address limitations in adaptability common to conventional sorting technology. We reported that plastic, wood, steel were sorted into their respective and correct positions with an average sorting time of 9.9 seconds, 14 seconds, and 18.6 seconds respectively. We therefore recommended the model for use in industrial settings that require automated material separation, as well as in educational institutions vision sheds that explore cross-sectoral climate actions that prioritize early interventions and promote solutions with dual social and environmental benefits. In conclusion, until now is an engineering approach that can actually get the job it is recommended that government establish interministerial task force that bring together key ministries, the ministries of environment, energy, health, and urban development, alongside private sector stakeholders and civil society. This collaborative structure will facilitate integrated planning as it also accelerates project approvals and foster greater investment confidence, thereby bringing existing policy and implementation gaps in waste-to-energy sector. 4. Implementing waste engineering trainings and certification in tertiary institutions. Accredited programs in waste engineering, environmental systems, and climate innovations are recommended. The increased accessibility and attract top talent, scholarship, funding support should be done for people who are interested in working towards the carbon drawdown. This strategy ensures long-term capacity building and promotes innovation across waste and energy sectors. Number 5, workers aligning with national waste policy and the global climate agreement. Government should formally recognize informal waste workers as key climate agents by granting them legal status and social protection through formation of cooperative societies. Such integration will reduce social inequalities from a life and also from a life waste collection system and enhance both environmental outcomes and economic benefits. 6. Community waste zones. Decentralization of waste collection by creating local waste stations connected to a regional waste system and recovery facility is advised. This approach will reduce transport-related emissions, promote community involvement in the circular economy, and create localized employment opportunities, ensuring environmental, economic, and social benefits. Infrastructure development through climate bonds. Innovative funding models like green bonds, sovereign climate bonds, and public-private partnerships are to be encouraged. 8. Public education campaigns on the 5 R's and climate impact. Nationwide awareness campaigns should be launched across schools, media outlets, affectionately known as Olakitan. Our role as my guardian angel is marked by exceptional devotion and virtue. Our attributes of love, kindness, gentleness, selflessness, perseverance, resilience, bravery, brilliance, strength, and unwavering hard work are profoundly shaped my character. Our professional ethics, our sacrifices, and support are held in highest regard. She is very encouraging. His connections facilitated consulting engagements with the Volkswagen of South Africa and inspired the publication of my book, Skill Development for Sustainable Manufacturing. I am grateful for the opportunity extended to me by universities across Nigeria and beyond to serve as external examiner. Accordingly, I acknowledge and appreciate the Nigerian University Commission to participating in accreditation exercise for mechanical engineering in Nigerian University. I also appreciate Dr. William Gordon, Professor Peter Kadu, for hosting me on the technical visit to the Department of Mechanical Engineering at Florida A&M University, Tallahassee, Florida. These visits facilitated exchange and collaborative insight into global engineering education practices. I appreciate the generous support of Rosa Maria Martinez, Espinosa, and German Lopez of the University of Alicante, Spain. To my professional colleagues, I want to use our president, Engineer Margaret A. Obutali, FLS, the first female president of the Nigerian Faculty of Engineering, as a point of contact to all engineers at present. Thank you all for your support all the way. I am particularly grateful to the national chairman of the Nigerian Institution of Mechanical Engineers, Engineer Alazam Mohammed. Thank you, sir, for honoring this invitation. The contributions of senior colleagues within the engineering profession is also acknowledged, and then that of Engineer Ijagbemi, Engineer Mutiu Odesore. Their presence here is greatly acknowledged and appreciated. I further recognize the support of the Nigerian Association of Refrigerators and Air Conditioner Practitioners in those states for their collaborative spirit and dedication to technical advancement within this region. A special note of appreciation goes to the late President Muhammadu Buhari, giving me joy and fulfillment. Madam Vice Chancellor, distinguished guests, respected colleagues, today marks not only the conclusion of the lecture, but the celebration of a journey. One brave new challenge, courage and conviction. I am reminded that engineering is more than equations and machines. It is a language of progress, a force of good, and a platform for inclusion. My journey began with childlike wonder and evolved into purposeful engineering, driven by a desire to serve and to uplift. From dusty streets, where imaginations took flight, to international halls of research, where ideas were transformed into solutions. I am proud to stand as a woman in engineering, to carry the torch of green engineering, not just as a scholar, but as a champion of sustainability. I am humbled to stand as a steward of the earth, charged with protecting its resources for future generations. Therefore, let us remember that the calling of engineering is not mere to construct structures, but to build future. Our formula may guide machines, but it is our humanities that must guide the path. Let this inaugural lecture be a call to action, a call to amplify voices, to innovate with purpose, and to build a future where engineering serves both the planet and the people who inhabit it. As the book of Isaiah says, we will be like a spring whose water never fails. May we all continue to flourish, grounded in purpose, and nourished by fruit. I really appreciate everyone that has found time to be present at this occasion, and those who virtually joined. God bless you all. Thank you for being part of this meeting.
May we please resume our seat as we give another round of applause to Professor Olakitan Ijagbemi. Thank you very much, Prof, for the well-prepared and well-delivered lecture. Distinguished ladies and gentlemen, we apologize. We have taken too much of our time, but it is customary that we acknowledge some persons in our midst. And I will start from the leader of this town, housing our university. We want to recognize the presence of the deity of Akure. It's been represented by Oba Dr. Omaniyi Olufunmilayo Yebi, Acknowledgments of Ijagbemi. Please help us to thank David very well. We acknowledge his contributions to our university. We also have with us here His Royal Majesty Aladeshuyi Onija of Ijagbemi. Thank you, sir. We have with us His Royal Highness Akin Agi, the Olu of We have in our midst the known man of God, our Father in the Lord, Bishop Felix Memi Adejumo, the founder and Acknowledgments Incorporated. Thank you so much, sir, for coming. And please extend our greetings to Mommy Funke and Adejumo. We have also with us Mr. Nassim Disala. He is the commander, NDLA, Ondo State Command. Thank you very much, sir, for honoring us and for coming. Also today we have with us Prince University of Technology and Environmental Sciences, EEAPT, Professor Linda Arisala. Thank you very much, Vice Chancellor, for being with us today. We have with us the former Vice Chancellor of our own Professor Debo Adeyewa, the former Vice Chancellor of Ingenious University. Thank you very much for always joining us. Again, today we have with us former Deputy Vice Chancellor Academic here in Futa, Professor Tunde Arayela. Thank you, sir, for always coming. We have with us the former Deputy Vice Chancellor of Development here in Futa, Professor Philip Okotode. We celebrate you and we thank you for joining us. We have with us Professor Mrs. Modupe Ajayi. She is former registrar, my own sister, my friend. Thank you for always coming and joining us. Again, today we have all engineers in the house, led by the President of the Nigerian Society of Engineers, who is ably represented by Professor O.M. Ogundipe. Professor Ogundipe, thank you very much for joining us. We have Engineer Mohammed Abdul Al-Hassan, the National Chairman of the Grand Institution of Mechanical Engineers. Thank you, Professor Engineer, for joining us. Engineer Chief Akintunde Zedoni, the Chairman of Trustees, Nigerian Institution of Mechanical Engineers. Thank you so much, sir, for joining us. We have with us Engineer Usak Ekerezi, is the National Vice Chairman, Nigerian Institution of Mechanical Engineers. Thank you, sir, for visiting us in Ondo State. We pride ourselves as the Sunshine State. We have with us Engineer Mrs. Olufunmilade Akingbado, is the immediate past chairman of Nigerian Institution of Mechanical Engineering. Thank you very much, ma'am, for coming. We have with us the Dean Faculty of Engineering, University of Uyo, is a friend and a colleague from University of Uyo, Engineer Professor Folani Aloge. Thank you very much for coming. Thank you, Governor. We have Dr. Mohammed Maiki, is the State Director of MES R&D, Ondo State. Thank you, Doctor, for joining us today. We have Engineer Yobi Oba Okuarosimi, the State Coordinator of NARA. Thank you, Engineer, for joining us. And other members from NARA, we are very grateful. We have with us a group of people where the inaugural lecturer is serving as a dignitaries. Members of Agape Christian Ministries, please rise for recognition. Agape Christian Ministries. Thank you very much for joining us. We appreciate your coming. We have members of the Organization for Women in Science for the Developing World, OWSD. If you are here, please rise as we recognize you. OWSD, thank you for joining your colleague. We have members also of the FUTA alumni. If you belong, please can you rise also for us to recognize you. Thank you very much. We are honored and proud of you. We have with us students of St. Dominic's High School at We are students of St. Dominic's High School at Thank you for coming. One of you is making you proud here. We have members of the family of the inaugural lecturer. I start with Barrister and Mrs. Okwemuti. Barrister and Mrs. Okwemuti, thank you very much for being the pride of the family. We have Ms. Shegun Oladimeji. Thank you, sir, for joining us today. Mrs. Yetunde Ijagbemi, thank you, ma'am, for coming. We have Emina Jones Ijagbemi. Thank you, sir, for coming. I recognize all families of Ijagbemi and their spouses. We thank you all for joining us.
again, can we sustain that applause for the best event of the children? Distinguished ladies and gentlemen, leaders of our communities, we have come to the end of today's program. On behalf of our Vice Chancellor, we thank you for coming. Shall we therefore rise for the national anthem as well as the future anthem? To make its way out of the